Hello, this is Mrs. Ward. I'm going to go over the review worksheet for Chapter 2. And remember, this one is only going up through Section 2.5. All right, so find the derivative using the definition of a limit. You're going to have to remember the limit definition. I will not provide that for you, but just a reminder, that's a limit as delta x approaches 0. And then I'm going to do f of x plus 8 delta x. So I'm going to do the square root of x plus delta x plus 1 minus f of x all over delta x. And then when I have them at this way, the square roots, remember, in order to simplify that, I am going to multiply by the conjugate. And if I multiply the numerator by that, I have to multiply the denominator by that. And when I do that, I'm still going to take the limit as delta x approaches 0. This will be x plus delta x plus 1, distributing the negative sign minus x minus 1, all over delta x times square root of x plus x plus 1 plus the square root of x plus 1. Then in the numerator, the x's will equal 0, the 1's will equal 0, and I'm left with delta x over delta x. So those will also simplify. Here, I'm going to still be taking the limit as delta x approaches 0. I'm going to have a 1 in my numerator, and then I'm going to have the square root of x, plus in place of delta x, I'm going to write 0. And so my final answer, so I'm going to write the derivative notation, is actually it's going to be 1 over, and I'm going to have 2 of these, so 2 times the square root of x plus 1. What you need to show me is you take the limit as delta x approaches 0, substituting the x plus delta x, showing me how you simplify, showing me the simplifying, so I want to see these being simplified and this being simplified. Finally, you have to show me substituting 0 for delta x. Then your final answer with the derivative notation. All right, use the result of part A to find the equation and change mine at point A2. So I'm going to put 8 in for my x in the derivative. So I'm going to have 1 over 2 times the square root of 8 plus 1. So it's going to be 1 over 2 times the square root of 9. So the square root of 9 is 3. So this is going to be 1/6. So my slope is 1/6. So I'm going to write y plus 2 is equal to 1/6 x minus 8. And when I do all of that, my final answer is going to be y is equal to 1/6x minus 10. And that is the equation of my tangent. And moving on to the next one, find the derivative using the limit definition. So again, the same process. Delta x approaches 0. I'm going to 1 over delta x plus 8. Or x plus delta x, minus 1 over x plus 8. And then this whole thing is over delta x. These ones have denominators, so I'm going to have to make sure I have the least common denominator. So I'm going to multiply by x plus 8 over x plus 8. And this fraction can be multiplied by x plus delta x plus 8 over x plus delta x plus 8. So when I do that, still taking the limit, as delta x approaches 0, this one will be simply x plus 8. Distributing this negative sign to this, I'm going to have minus x minus delta x minus 8. This is all over my common denominator, x plus 8 times x plus delta x plus 8. And again, this whole thing is still over delta x. So here in the numerator, the x's will equal 0, the 8's will equal 0, and I'm left with just this negative delta x. My denominator is x plus 8, x plus delta x plus 8. Then this I'm going to think of as delta x over 1, change it from division to multiplication, make the reciprocal. Now the delta x's will simplify. So I'm going to have a limit as delta x approaches 0, negative 1 over x plus 8, and then in place of this delta x, I'm going to write 0. So now my final answer, which letter I had, G. So G of x is going to be a negative 1 over x plus 8, and we're multiplying to them, so x plus 8 squared. Okay, moving on to the next one. After that, after it said, when it doesn't say limit definition anymore, then use your properties if you're going to find the derivative. So I'm going to find the derivative of the following. So I'm going to rewrite before I do that. I'm going to rewrite this as x to the 1/2 minus x to the negative 1/2. Now when I find the derivative, I'm going to multiply by the power, reduce the power by 1. Multiply by the power, so this would be negative 1/2. Reduce that power by 1, so that would be negative 3/2. So since these both have the same denominator as an exponent, I'm going to factor out the lowest one. So I'm going to factor out x to the negative 3/2. And while I'm at it, I'm going to factor out a 1/2. And that's going to be times 1/2. This will just be x plus 1. So then writing it without a negative exponent, my numerator is going to be this x plus 1. My denominator is going to be 2x to the 3/2. And I'm going to do that because they had a common denominator for the exponent. Here, when I go to find the derivative, I have to do the quotient rule. So to do the quotient rule, I leave the denominator alone. Take the derivative of the numerator, which is just 1, minus leave the numerator alone. Take the derivative of the denominator, which is just 1, all over my denominator squared. So when I do this, I'm going to have x plus 2 minus x plus 2 all over x plus 2 squared. If x's will equal 0, so I am going to have my final derivative as 4 over the function x plus 2 squared. And moving on to the next one, we're still finding the derivative. I'm going to rewrite first. So if I rewrite, this is going to be t to the 1/3 t squared plus 5t. I may choose to distribute the 1/3 so I don't have to do the product rule. So remember, if I'm distributing this, I'm adding my exponents. So if I add 2 plus 1/3, that'll be t to the 7/3 plus 5t to the 4/3. Now I'm going to use the general power rule to find the derivative. And I'm going to have 7/3 t, subtract 1, and that would be 4/3. Plus, I have this 5, I'm multiplying by 4/3 t, subtract 1 from that, and that's going to be 1/3. So I am going to so let me do it. This is 20 to the 1/3. They have the same denominator, so I'm going to factor out the lowest denominator. The lowest denominator is t to the 1/3, and then I might as well factor out a 1/3 while I'm at it. So I'm going to be left with 7, and that's just t to the 1st, plus 20, and factor that t to the 3rd. And that's it. I don't have to rewrite it because my exponent is positive, and that one is good to go. Another one on here? Nope. Page. So this one, I have the choice of either foiling first and then taking the derivative, or I can take the derivative using the product rule. I'm going to go ahead and do the product rule. On the answer command line, I showed both ways, but I'm just going to do the product rule. So I'm going to take the derivative of this 3x squared, which will be 6x. I'm going to leave this x squared minus 2x plus 3 alone. Plus, now I leave that 3x squared plus 7 alone. Take the derivative of the second one, and that's going to be 2x minus 2. Now, when I distribute the 6x, I'm going to have 6x to the 3rd minus 12x squared plus 18x. And I'm going to FOIL these two, and I'm going to have plus 6x to the 3rd minus 6x squared plus 14x minus 14. Combining all my like terms, I'm going to have 12x to the third minus 18x squared plus 32x raised 14. And I could factor out, well, I think it's fine, but I can factor out 2. And there I have my derivative simplified. Okay, moving on, I have, I'm going to use the chain rule. I have a quantity raised to a power. So when I use the chain rule, I'm going to use the general power rule, bring that 3 down. Leave the parenthesis alone exactly the way I see it. Reduce the power by 1, so this is now raised to the second power. Now I multiply by the derivative of what's inside, which is 2x minus 4. And now I am going to rewrite that. So there's what I have right now. I notice that I can factor out a 2 from here, and it's linear, so I'm going to do that. And then I factor out the 2, 3 becomes 6. And that's my final answer. For the next one, I'm doing the chain rule with the quotient rule. So I'm raising something to a power, so I'm going to bring the power up front. Leave this exactly the way it is. Reduce the power by 1. So this is going to be raised to the first power. Now I multiply by the derivative, so I'm going to have to use the quotient rule. Leave the denominator alone. Take the derivative of the numerator minus. Leave the numerator alone. Take the derivative of the denominator, which will be 2x. And this is all over my denominator squared. So I have 2 times x minus 3. And then this, I'm going to kind of cheat here for a second. This is x squared plus 1. And minus, and then this will be minus 2x squared plus 6x. So then when I combine my like terms, I'm going to have negative x squared plus 6x plus 1. And this is all over. I have this x plus 1 times x plus 1 squared. X plus 1 squared raised to the third power. And that is my G, I'm going to rewrite before I do it. So I'm going to have x squared minus 1, raising it to the 1/3 power. Doing the general power rule, I'm going to bring that power down, leave the parenthesis exactly the way it is, reduce this power by 1, so 1/3 minus 1 is negative 2/3. Multiply by the derivative of what's inside, which will be 2x. So when I do my derivative, I'm going to have to rewrite this so that I don't have a negative exponent. This 2x is in the numerator. This 3 and this x squared minus 1 is in the denominator. Now that power becomes positive since I moved it to the denominator. Okay, the next one, I am going to do the product rule and the chain rule. So I have this 4x times this secant squared x. This I'm going to have, when I take the derivative of this part, I'm going to have to use the chain rule to handle everything that's going on here. So let's start by taking the derivative of 4x, which is just 4. We've got secant squared 7x alone. And just remember that secant, that 7x squared. I'm going to rewrite that, then plus. Now I'm leaving that 4x alone. I'm taking the derivative of something raised to the second power, so I'm going to bring down that 2. Leave the parenthesis alone exactly the way it's written. Raise it to the 1 less power, so that's going to be raised to the first power. Now I'm going to take the derivative of secant. Remember, the derivative of secant is secant times tangent. And this whole time, I'm not changing that 7x. That 7x will stay the same. And now I take the derivative of what's inside. So now I'm taking the derivative of that 7x reduced to 7. So when I do this, this first one will just sort of stay the same. Then I have 4 times 2 times 7, so that's going to be 56x. I have 2 secants, so that's going to be secant squared 7x. and 1 tangent. Now I can factor out from both terms, I can factor out a 4, and I can factor out a secant squared, 7x, and I'm going to be left with 1 plus 14x times tangent of 7x. And that is my final answer. Find the second derivative, so I'm going to rewrite first. So when I rewrite, this is going to be 12x to 1/4. Finding the first derivative, I take 1/4 times 12 and I get 3x, subtract 1 from that power, and it's negative 3/4. Now, if I had to rewrite the first derivative without a negative exponent, that would be 3 over x to 3/4. But I'm going to leave it like this to find the second derivative. So to find the second derivative, I'm going to take that 3 times negative 3/4, get negative 9/4 x, subtract 1 from that power, so that will be negative 7 over 4. Now, since this is my final answer, I have to write it without a negative exponent. So here's the negative 9, here's the 4, x to the 7/4. And that is the second derivative. Okay, find the equation of tangent line at the indicated point of 3.5 for the function 2x over 1 minus x squared. So first thing I have to do is I have to find the derivative. So to find the derivative, I'm going to leave that denominator alone. Take the derivative of the numerator, which is just 2, minus, leave the numerator alone. Take the derivative of the denominator, which is a negative 2x. And this is all over my denominator squared. So when I do that, I'm going to have 2 minus 2x squared plus 4x squared all over 1 minus x squared squared. So then my final derivative is going to be 2x squared plus 2 over 1 minus x squared squared. Now I can factor out a 2 from the numerator, but I don't have to because it's sort of a work in progress. So that's my derivative. So now I'm going to put in 3 because I want to find the derivative at that x value, which is 3. So we have 2 times 3 squared plus 2 all over 1 minus 3 squared squared. So when I do that, my numerator ends up being 20, 9, 18, 20. And then this is 9, so that's negative 8, 8 squared, 64. And in lowest terms, that's going to be 5/16. So that's the slope of my line. It gives me the point. There's the point, so I'm going to do y minus, and I did 3/4 is 7.75, sorry. And then 5/16 is my slope, and then x minus 3. And when I solve all that, I get y is equal to 5/16 x minus 3/16. Now, if you use 0.75, you're going to have decimal, which is fine. Moving on, use implicit differentiation to find the derivative. This is when we're taking the derivative of y in terms of x. So when I take the derivative of x squared, that's just going to be 2x. Plus, have to use the product rule, so I'm going to take the derivative of the x first, so this will just be 3. The derivative of x is 1, so 3y. Plus, now I'm going to take the derivative of y, so the 3x stays the same. The derivative of this y is going to be dy dx. Plus, now taking the derivative of y to the third, 3y squared dy dx, and then the derivative of 10 is 0. Just to remind you that this 3x has to do the product rule, and this is the derivative using the product rule. Do not forget to use the product rule. All right, moving on. So I'm going to put everything with the dy dx on one side. So these guys are going to stay on this side. The other two things are going to go on the other side. So I'm going to have 3x plus 3y squared. Both of these have a dy dx. And then on the other side, I'm going to write negative 2x minus 3y. Now to solve for dy dx, I'm going to divide by this. So when I do that, I'm going to have dy dx is equal to negative 2x plus minus 3y all over we have to have 3x plus y squared. Now, I think when I'm looking at my answer key as I'm doing this, I actually have 2x plus 3y, but then down here I have a negative x minus y squared. So same thing, just the negative sign switches from the numerator. This one, still doing the implicit differentiation, so the derivative of this y squared will be 2y dy dx. And then I believe I used the product rule. I did. The derivative of x is 1. The derivative of y is dy dx, and then I left this x squared plus y alone. Now I'm going to leave that x minus y alone, take the derivative of x squared, which is 2x, take the derivative of y, which is dy dx. And I must finish later. Okay, so I'm going to put everything with dy dx on one side, everything without the dy dx. Oh, I haven't done it yet. Sorry. I am going to have to multiply these two things. And by these two things, I mean I'm going to have to multiply these two. So I'm going to have to FOIL this, and I'm going to have to FOIL these two. Then I'm going to take my dy dx to one side. So this 2y dy dx is just going to hang out to the left for a second. Then when I FOIL this, I'm going to get x squared plus y. That's me multiplying 1 by everything. Then I'm going to multiply this negative dy dx by everything. So then negative x squared dy dx, and then a negative y dy dx. Plus, now I'm multiplying everything by x, and I'm going to have 2x squared plus x dy dx minus, now multiplying by that y, 2xy minus y dy dx. Now there's a lot of dy dx's, so I'm going to highlight. So this is a dy dx. This is a dy dx. I'm going to highlight the negative sign so I remember to bring it. This is a dy dx. Another dy dx. And another dy dx. So I'm going to take those 4 things to the other side with the 2y. And then while I'm doing that, I'm going to factor out dy dx. Times, so I'm going to do dy dx times, and then there's this 2y. Now when I bring this stuff over to the other side, the signs are going to change, so plus x squared plus y plus x plus y. I guess it should be minus is equal to, and then everything over there, x squared plus y plus 2x squared minus 2xy. So I'm going to combine my like terms over here. I did not see that earlier. So I'm going to have these two. So I'm going to have one, two, three. I have 4y plus x squared. And then over here, I'm going to have 3x squared minus 2xy plus y. And now I'm going to divide by whatever's with the dy dx. So I'm going to divide by this 4y plus x squared. It does not matter the order that you write these terms in. So my dy dx is equal to 3x squared minus 2xy plus y, and then I have 4y plus, I didn't put it in, and that's my final derivative. Okay, the next one, find the points. So once points, so points means that you're going to give an xy. Just verifying that you remember that, which a graph has the equation of the horizontal tangent line. So I am going to first find the slope. So to start to find a horizontal and then vertical tangent line. So this will be 2x minus, now I'm going to have to do minus 6 plus 2y dy dx minus 10 dy dx is equal, the derivative of 9 is 0, so this is going to equal 0. Just remember, anything that has that y, so this has a y, and this has a y, which means when you take the derivative of that dy dx. So now I'm going to do it the same way I did before, when I'm going to do the dy dx. I'm going to leave them on this side, so that's 2y minus 10. Everything else is going to go over to the other side, so this will be a negative 2x plus 6. So I'm going to divide by 2y minus 10. So when I do that, I'm going to say dy dx is equal to, and I'll factor out, like, let's say 2 times negative x plus 3 over 2 times y minus 5. The 2's will simplify, so I'm left with a negative x plus 3 over y minus 5. So it wants a vertical tangent line. So the vertical tangent line, oh, let's do the horizontal first. The horizontal tangent line is when the function, or when the derivative, so this dy dx is equal to 0. So in this case, the only time that's going to happen is when the numerator is equal to 0. So I'm going to take that negative x plus 3, set that equal to 0, so x is going to equal 3. It wants points, though, so I'm going to have to put that 3 in for the x and solve for y. So I'm going to have to do 3 squared minus 6 times 3 plus y squared minus 10y plus 9 is equal to 0. So this is 9. 9 is 18. So all these will equal 0. So I'm going to put y squared minus 10y equals 0. Y is equal to 0. Y is equal to 10. So my two ordered pairs are going to be 3, 0. And 3, 10. Those are my horizontal tangent lines. Now to find the vertical tangent lines, that happens when my derivative is undefined, and that's going to happen when my denominator is equal to 0. So this y minus 5 is equal to 0, which means y is equal to 5. Same thing, I have to find the points, so we substitute 5 back into that original equation. So we're going to have x squared minus 6x, and then plus 5 squared minus 10 times 5 plus 9 is equal to 0. So this is 25. This becomes x squared minus 6x, 25 minus 50 plus 9 will end up being minus 16 is equal to 0. So this factor says x minus 8. X plus 2. So x is equal to 8 and x is equal to negative 2. So my ordered pairs are going to be 8, 5 and negative 2, 5. And those are my vertical asymptotes. Moving on to the next one, find the second derivative. So I'm going to first find the first derivative to find the second derivative. So I'm going to say the first derivative is equal to 2x minus 6y dy dx, and the derivative of 27 is 0. So I'm going to have 2x is equal to 6y dy x. Divide both sides by 6y, so I'm going to get x over 3y is equal to my first derivative. Now to find my second derivative, I'm going to take, that's these two mean the same thing. To find the second derivative, I'm going to take the derivative of that. So to find the second derivative, I'm going to do the quotient rule. So I'm going to leave the denominator alone, take the derivative of x, which is 1 minus the x alone, take the derivative of the denominator, which is going to be 3 dy dx, and I'm going to put this all over my denominator squared. So when I do this, I'm going to have we have 3y minus 3x times, in this first derivative, I'm going to take this and substitute that into my dy dx, times x over 3y. And this is all over 9y squared. So when I clean that up a little bit before I simplify, 3y, the 3's will simplify, minus x squared over y, and this is all over 9y squared. Get rid of this y in the denominator. I'm going to multiply the numerator by y, which means I have to multiply the denominator by y because then I'm technically multiplying by 1. And when I do that, I get 3y squared. These y's will simplify, minus x squared all over 9y to the third. Now, chances are, and while it seems to always happen, that's going to look like something like this. Well, the x squared is positive, the 3y is negative. So I'm going to factor out a negative, well, I'm going to go here and I'm going to think of this as a negative 1 times, now my x squared becomes positive, my y squared becomes negative, and this is still over 9y cubed. Then that is equal to 27, so I'm going to put 27 in for that, so it's going to end up being a negative 27 over 9y cubed. This is still my second derivative, but then of course I'm going to simplify the negative 27 and 9, so negative 3 over y cubed will be my final answer. That's a lot of fun. Now doing the last one. I find the equation of the tangent line to the graph of that passes to the point 25. And remember that 25 is not on the graph. It says not on the graph. So if you want to visualize it, you have a parabola that opens down. You have this point 25 somewhere, and you're trying to find the point you're trying to find the equation of the tangent line or lines that are perpendicular or parallel. No, you're trying to find the equation of the tangent line to this graph that pass through this point, which is 25. So I'm going to pick some point here. I'm going to call this xy. I'm going to find the slope between these 2 points. So I'm going to do the difference of the y's over the difference of the x's. And then to find the slope of the tangent line at this point, that's going to be the derivative of this, which is going to be 4 minus 2x. I'm going to set those two equal to each other because they are one in the same line, so they have to be equal. So now I'm going to solve this. I'm going to multiply by x minus 2 and this by x minus 2. And when I do that, I'm going to have y minus 5 is equal to, remember I'm foiling that. And when I FOIL that, I am going to get negative 2x squared plus 8x minus 8. Add 5 to both sides. Negative 2x squared plus 8x minus 3. Now this y is going to be the equation. This f(x) is the same thing as y, so I'm going to put in that 4 minus x squared. 4x minus x squared. Now I cannot product sum without my lead coefficient being positive, so I'm going to take everything over here. So my lead coefficient positive is quadratic, so I have to set it equal 0. So when I add x squared, 2x squared, this is going to be x squared minus 4x plus 3, and this is going to equal 0. Now this is very simple for the product sum. My factors of 3 that add up to 4, 3 and 1, both are going to be negative. So I'm going to get x is equal to 1, x is equal to 3. So this happens at this 2, 5, which I guess I should put 4 in the middle. This point here is going to be 1 something, and this point here is going to be 3 something, and both of those are going to be tangent lines with a graph that carries through that point 2, 5. So it just wants the equation of the tangent line. So I have to find the slope of the tangent line. So it should make sense to you that this slope is going to be different than this slope. So I'm going to find the slope at 1. So to find that slope at 1, I'm going to put 1 in here. So I'm going to find f(1) at the derivative at 1. This going to be 4 minus 2 times 1. So that slope is going to be 2. It doesn't ever ask me for the point, so I really don't have to find the point because I can use it for 0.25. So I'm just going to do that. I'm going to go lazy today. So I'm going to do y minus 5 equal to 2 times x minus 2. And when I simplify that, I'm going to get y is equal to negative, y is equal to 2x, what's the 2x plus 1. So that's one equation. Then when I find the derivative at 3, that's going to be 4 minus 2 times 3. So that's going to end up being negative 2. So again, still using that 0.25 because both volumes go through 2.5. I'm going to do y minus 5 is equal to negative 2 times x minus 2. And when I do that, I get y is equal to negative 2x plus 9. And that's my second one. All right, those are the answers. I hope this helps, and I will see you next time.